Good morning or good afternoon, everybody, and welcome to everything you need to know about getting started with Solo and PLS Toolbox. And oh boy, isn't that great? Um, uh, and okay, that really put me off my game there. Uh, uh, okay, I'm Barry Wise, President of Eigenvector Research, and today two of our developers, Scott Koch and Lyle Lawrence, are going to take us through this, and I'm excited to hear their presentation on the best way to get going on this. Generally, the way we work this when we're uh, doing these is we leave everybody muted except for the presenters. And if you have a question, please use the chat function to enter that. We'll have a couple of the other Eigen guys monitoring the chat. And they'll either answer your question there in the chat or I'll ask Scott and Lyle to answer the question. And with that, I'm going to turn it over to Scott and
Someone needs to.
have at it, Scott.
And I will stop calling you, Barry.
Okay, thank you.
Thanks everyone for joining this morning. I'm just waving at you from my camera here, but I'm gonna turn it off here to conserve some bandwidth. So we're gonna go through sort of the basics of how PLS Toolbox is organized, getting started, like installing, and some of the fundamentals of the technology that we use. And we really want you to ask questions in the chat so we can steer this to what your needs might be. And so don't hesitate to post a message there. All right. Our webinar is being recorded and will be posted shortly after we're done here in a day or two. I'll be using PLS Toolbox with MATLAB, and I'll be using our current version, which is 8.9.1 for my demonstration. When I hand it over to Lyle, he's actually going to be using our compiled product, which is Solo, and we'll talk about that in just a second on what the differences are there. We're going to start with a organization of our software, then go into installation, and then our main interface. And then we're going to spend, a good chunk of time on importing data and then how our data is organized in the data set object. And then we'll talk about the modeling interface. We call it the analysis interface. And then finally, we'll wrap things up with some plotting using our plotting tool. And then our final slide will show how to access help. So we use MATLAB, which is a product of the MathWorks. It's a suite of tools that are used for technical computing, often in engineering and science. And our product, MathWorks offers a lot of products. They have their core product is MATLAB, which is an integrated development environment, an IDE, as well as a language. They also have Simulink, which is sort of a graphical engineering environment, and then they have a host of other products that they offer, and as well as consulting and other specialty items. Within MATLAB, there are a bunch of extra add-on toolboxes. For example, they have the database toolbox for connecting MATLAB to databases, and they have the stats toolbox that has extra statistics packages. Our toolbox, the PLS toolbox, only requires MATLAB. And within MATLAB, the integrated development environment, there's the language itself, MATLAB. There's a file editor, which includes a debugger for going through your own code, as well as visualization tools, the command line, and then you can actually build your own interfaces with MATLAB. And we use those tools quite a bit to make our product, PLS Toolbox. And then when you get to our product, we have PLS Toolbox, which runs within MATLAB, and we have our interfaces, which build models and allow you to analyze data. And we organize our code in sort of a hierarchy where we have really numeric functions that just operate on the numbers. We call them engine functions. Then we have a layer of functions above that and objects that will take these engine functions and data and give you an object that you can work with. And then on top of that, we build interfaces that allow you to drag and drop and build models and analyze data from a point-and-click environment. And we take all of that, all those tools, and we compile them into a standalone application, and that's what Solo becomes. And the only difference between Solo and PLS Toolbox is you don't have access to the MATLAB command line. If you're the type of person that just really only wants to point and click, then Solo is the product for you. If you have a more complicated environment where you might need to do some specialty programming, or you're finding yourself having to do a lot of manual things, pointing and clicking the same thing over and over again, that's something you might want to consider using MATLAB and PLS Toolbox for so you can automate things. The next sort of product line that we have is for deployment. So if you have a model that you want to deploy online, for example, you can use our Solo Predictor product or our Model Exporter product. We're not going to go into a lot of detail on those here, but I thought I'd mention them. So, further down the line, after you get started and you really find yourself in wanting to build an application within your environment, these are the products that our customers use. And then we also offer some consulting and custom software when there's a bigger task that you need our help to do solve for yourself. Okay, installing PLS Toolbox and Solo is straightforward, but with MATLAB it just takes a few steps. And what it involves is taking the is going to the PLS Toolbox folder after you've downloaded it, and then running the installation script. And if you're a first time to MATLAB and PLS Toolbox, it just doesn't feel natural, So often, I think most of the people will download our exe installer, which runs all this automatically. But I'm going to switch over to MATLAB here. Actually, I'm going to switch over to my Finder here, to my file system, and I'm just going to go through real quickly how to manually install PLS Toolbox. And I think this will allow people that end up doing this just a real quick overview. So I downloaded the PLS Toolbox zip file. I decompressed the zip file to its folder. I'm going to copy this, and I'm going to go to my MATLAB folder that's the default for Macs. I'm on a Mac right now. I'm going to paste that folder into this default home folder for MATLAB. And I'm going to go, I had MATLAB already started, but this is what MATLAB looks like when you start. And then I'm going to make PLS Toolbox my current folder. Your current folder is up in this toolbar here, but I'm going to go to make this PLS Toolbox my current folder here. And now all I have to do is run that script that we mentioned in there. It's EVRI-install, EVRI install. And this brings up our installation interface. And the only other thing I need to do here is go get my license code. So I don't actually have my license code memorized. So I'm going to go to my account on our website and grab it real quick here. And in the download section of my account, I'm going to scroll down to PLS Toolbox. And here's my license code right here. I'm going to copy it. And also note that if I wanted to use an older version of MATLAB, or sorry, of PLS Toolbox, I'd have to go get the particular license code for that older version. I'm going to switch back to the installation here. I'm going to paste my license code in there. I can click check to double check it. I see down here that the new license is valid. I'm going to go ahead and hit install. And I'll agree to the terms of the license to continue. And now PLS Toolbox is just adding these folders to the MATLAB path and then doing some double checks. And it doesn't take too long. And what we'll do after it's done is open our primary workspace. And in order to launch this workspace, I get a little note here. If I want to launch this workspace from MATLAB again, all I have to do is type the word browse and hit enter. I'm going to close that. I'm going to say I'm done. And I'm back here at the workspace. I had another version of PLS Toolbox installed here just a little while ago, so I got this little warning, but I can ignore that. All right, I'm going to go back to my presentation here. And so what I just did there manually is what our exe file for installing PLS Toolbox will do. Solo is very similar in how you would install almost any any application in Windows or Mac. You'd really just run the exe when you're on Windows, and in Mac you just take the app and drop it into your applications folder. The only situation we see with Solo, sometimes it requires, depending on the user's admin rights, it might you might need to run it as an admin in order to install it. And then, as I mentioned there in my little demo, license codes are version dependent. So for a major version, so if you're moving from version 8.9 of our software to 9.0, you would need to get a new license code. So next I'm going to move into the workspace browser. I'll double check with Barry to make sure that we don't have any questions. But the browser is...
there is a question, Scott, and
okay.
That is that PLS Toolbox is updated periodically, and I would say please regularly, quite often. What about its manual? What is the current version of its manual?
Okay. Well, we sort of have two major pieces to our manual. One is sort of the software piece, which is how to use the software, and the particulars about the functions, and that's captured in our wiki. I can show you that real quick, and we'll touch on this when we get done. But if I go to my account here, I actually have I have a shortcut to it that I'll just go to right now, but we can get to it from the web page as well.
I normally click on the support button up there to get to it.
Oh, okay. Let me go back there. I never go this direction. Okay, so if I go to the support button, then you can visit our wiki. This is the most up-to-date documentation we have on the software, and we're constantly updating this, every few days with little tweaks. And then we take a snapshot of this and we include it with the software when we bundle it up and ship it. There's also a chemometrics um, tutorial. This is sort of the more theory behind it, and it doesn't change very often because the methods and the theory behind all the math and the details of all that don't change very often. So this sort of has outdated screenshots in it for the limited screenshots that we do have of our software, but otherwise this goes into detail on our chemometrics background. And so if you're interested in getting up-to-date software information, go to the wiki. Okay, I'm going to run through some items on our browse interface. There's 3 panels. The upper right panel is the workspace. That's where you can interact with your data. The lower right panel here is the model cache. When you calculate a model, you get a copy of that model and the data used entered in this cache, and then that's saved, if you will. And then a list of all of our functions and tools are over in this panel here in the analysis tools area. If you double click on a demonstration data set over in the cache area here, it will load into your workspace. From here, you can drag and drop it to whatever analysis you want to do. I'll drag and drop this on PCA, and that will open up the analysis interface and load the data. And then I'm ready to start building a model. I'm going to leave that to later. I'm going to go back to my my browse interface here. A lot of items, and it's not just with the browse interface, have right-click menus. So if I right-click on an item, I can see things that I can do with it. I can plot it, I can edit it, I can save or delete, and then I can export it or move it, or send it to an analysis here. And I encourage you to right-click on things to see what's available to them. And then we also have menu items up here for doing a lot of those same things for workspace items. And then I also note one more thing here. If I load my, I'm going to load another demonstration data set. This has 2 data sets that are the same size. I just wanted to let you know, you can drag and drop these on top of each other, and then it will allow you to concatenate them. Because of the same size, I can concatenate in the rows or columns. And if I had multiple items, I could drag and drop a selection of data on top of an item. All right, I'm going to go back to the presentation here.
Hey Scott.
And yeah.
Hey, so this is Lyle. I just wanted to say one more thing about I think demo data is very useful. Um, is if you're doing something in the software with your own data and you're getting errors and you're not sure why, one thing we often recommend on Help Desk is to try that same action on a demo data set, because these data sets have been cleaned up and they work nicely in the software. So that's another use of a demo data set is making sure the action you're doing works on a cleaned up data set, and so that should point to that something might be up with how your data is organized.
Yeah, that's a good point. You can eliminate the idea that if it's a problem with your data or if it's a problem somewhere else. So just sort of a review here. You can right-click on objects and see what actions you can perform on them. You can drag from the workspace into an analysis to open it. You can drag items on top of each other to concatenate. And then you can right-click in the empty space in the workspace there if you want to create a new data set. And then I'm going to hand this over to Lyle real quickly or shortly here, and he'll talk about importing data. And then you can also I'll run back here real quick, because you can, if you have things that you use all the time and you don't want to go hunting for them, you can add them to the favorites up here. So if you find yourself doing an MCR, you can right click on the MCR item here and you can add it to your favorites and it'll show up here. I can go over this slide here, Lyle, or do you want to start with this one?
I was going to start with this one.
Okay.
So I'll steal the ball, or maybe Barry has to give it to me.
Yeah, just a second. Let me see. I have to find you in the list, Lyle,
Okay.
because you're down here as every Lyle, or who are you in here as?
I'm Lyle-Every.
Lyle dash every.
Yeah,
Okay.
I got it wrong.
Okay. And I'm gonna make you the presenter. Change role to presenter. And I think you are the presenter now.
Yep. Okay. Does that show up okay?
It does.
Okay, cool. Um,
And I just accidentally muted you, Lyle, when I meant to mute myself.
oh,
So,
I got you. Okay.
okay.
Um, so Scott just showed installation on a Mac, and installation on a Windows is very similar to that. So if you're a Windows user, it's very similar to what Scott showed. And so I just want to show a little bit about how Solo and PLS Toolbox is organized, and this kind of gets to the idea of importing, which is after installation, the next step to using the software is importing your data in, so you can start, exploring it and modeling it. But this flow chart here is really trying to show, starting with raw data, you import your data into using one of our file reader functions, and this is going to create a dataset object, which is a very important piece of the software, and it contains your data and any metadata. And we'll show more about the dataset object in a little bit. But from this dataset object, we use that to preprocess your data, and then you can pass it to PCA functions or different analysis functions like PCA, and this creates every model object. And that dataset object and every model object, they're shared. So this is just showing the importance of really importing your data, making sure it's imported correctly, getting it into the dataset object so that it can be used throughout the software. So we did a webinar last May about importing data. So I won't go through everything that was on that webinar. It's about an hour long, and it's a very good resource. So I highly recommend watching that if anything we cover here or anything that's discussed here doesn't cover what you're looking for. And I like to think of importing as a checklist when you start to think about importing. So the first thing to think about is, does Solo or PLS Toolbox have an importer for that proprietary file format? So this would be like a Bruker Opus file or a Thermo Fisher Omnic file or a Perkin-Elmer file. So, check our list of importers, which you can see here on the screenshot, and I'll show it in real time coming up. But we have quite a list of importers. So check first and see if we have an importer for that file type. And then if that's a no, if we don't have that, then see if that instrument software can export to a standard file format. So this would be something like a JCamp or a Galactic Thermo SVC file, or for like mass spec data, like a NetCDF file. And then if that's a no, see if you can get your data into an Excel file or a CSV file. And I just want to mention here real quickly that we do have importers for images. So you can see, so you'll need Mia Toolbox or Solo plus Mia to access those importers for images. And you can import several common image file types like JPEG and PNG, and then some file format specific for like TOF Sims data. So that is there if you have Solo Mia or Mia Toolbox. And we like to say if you can get your data into Excel, then you can get it into Solo or PLS Toolbox. And more specifically, if you can get into a CSV format, that's seems to be the better way to import data, is in using a CSV format. And I'm going to go through an example in a little bit showing importing a CSV file. But what you'll see when you do that, I like to use our import tool window. And this window allows you to set rows as columns that come in as data or labels or class or axis scale or included, or you can ignore. So this gets to the idea of creating the dataset object from your data that you're importing, because this is now, it has data and metadata with it. And one important thing about the import tool window is it's going to show the first 50 rows and columns, but it will import all your data. So a lot of times we see people get to that import tool window and it's only showing the first 50 rows and columns, but they have more data than that and they think that it's not importing all the data. It is importing all the data, it's just showing the first 50, so you can set your rows and columns to come in as you want. Which goes to another kind of important point when you're working with a spreadsheet or CSV file or Excel file, and you want to bring it into PLS Toolbox or Solo eventually. It's kind of good to start with that in mind, kind of start with the end in mind, and make sure you don't have any metadata at the end of your spreadsheet. Make sure it's all at the front. So when you get to the first rows or columns, so when you get to this import tool window, you can set those columns to come in as you want. And so after importing, we have now gotten to our dataset object, which is where we want to be, so we can use our data and metadata throughout the software. So what is our dataset object? So this allows us to keep data and metadata together. And it's a custom MATLAB class used widely throughout PLS Toolbox and Solo. So it allows us to keep data organized and it assures consistency. And there are multiple ways to create it. Like we mentioned, the best and most common ways by importing your data using one of our file readers. So that'll create a dataset object. You can do things like create a new dataset from the browser window. And you can do this. It's not used very often, but it's there. So I just want to mention that. You can do it from the MATLAB command line if you have PLS Toolbox and MATLAB. Here's a little screenshot of just a quick example. I created a random set of data and then called the dataset function on it and then created a dataset that way. And now in my workspace browser, in my browser window in the workspace, I can see I have a type dataset here. And continuing on about the dataset object, what all is in it? So it's got the data and all information in a single variable. So it has labels and axis scales and class information, author and modification dates and description. And so these are all things that metadata that's very useful for you to keep track of and help you explore your data better. It does provide consistency tests for axis scales and labels. So if you have axis scales and labels in your dataset object and you try to combine data sets that have axis scales and labels, it's going to do a check to make sure those match up. And if they don't, it'll run a function called match bars on it to try and make it as consistent as possible. So it allows easy classing and exclusion of samples or variables. So you can easily go in and select samples to be included or excluded, and you can do that for variables as well. And you can easily set classes, and I'll show some examples soon of that. Smart concatenation. So like Scott showed when he did his drag and drop demo just now. It asked if you want to concatenate in rows or columns, so that smart concatenation is available in when using dataset objects. You can put any information in the description field that you want. So you can just go in and type any type of information or data. It does have a history field associated with it. So all of this is available, and so it makes all this available to PLS Toolbox functions. And also know that this dataset object is a public, or it's a free, open source and open code, and you can download it. It does come with PLS Toolbox, but you can go and download it if you want to. I'm going to get out of my PowerPoint, and I'm going to go to Solo plus Mia. So I have Solo plus Mia open here, and I just want to show a little bit. So I mentioned the importing data. So if I go to File, Import Data, we see the list here of formats that we can import. So this, you're kind of broken up into section here, this first section, and then this second section is going to be where you can find proprietary file formats or standard file formats. And so I recommend looking through that list and see if that file format that you work with often is in this list, and then and then it should import nicely. And then we have, since I have Solo plus Mia, I have access to our image file importers down here at the bottom. So they are there. So as you see, this list is getting pretty long. We have quite a few ways to import data. And I just want to show one example here. So I have some galactic, I have some SBC files here. So I have, about 30 of them. Multiple ways to get it into the software. I could simply click, drag and drop into my workspace, and then it'll load it that way. Note I can do, I'm on a Windows, so I can do a shift click and select multiple and drag and drop that way. So that's an option. And then other way, I can go through the file menu option here and go and find SBC in the list, and then import that way. So yeah, so just a few different ways to actually get, the mechanics of getting it into the software. So now I have my SBC files in a dataset object, and now we can start modeling. I want to show an example of using a CSV file. So I'm going to go File, Import Data, and I'm going to select Excel file. Actually, I need to change the directories here. I'm going to select this CSV file. Actually, hold on. I'm doing this in wrong order. I want to open this file first. So I'm going to open up this gasoline NIR data file. So what we see here is we got some NIR data. We have some wavelength information here on the second row. We have this first row called include. So this is in the include field. So this is wavelengths I want to use in the modeling. So this is something you would find out through modeling, perhaps. But I just want to show an example that you can bring this data in during importing. We have an index column here that I will not too interested in, but we can ignore that. And then I have a sample label and then class information. So this is what I want to bring into Solo here. So I'm going to close this. And then I'm going to go File, Import Data, Excel file, navigate to this file. I'm going to say Open. And it's gonna parse. What it tries to do is it tries to parse the information. So anything that it sees as a number, it's gonna assume is data. Anything that has letters or strings, it's gonna assume is a label. So here you can see this first column here. It's assuming it is data, but it's actually not data. And we actually I'm going to say ignore. So this is this is our import tool window. So this is the one I was saying only shows the first 50 rows or columns, but it will bring in all your data. And you can set how you want your data to be imported in this window. So here, this first column, I don't want that imported, so I'm going to say ignore. And then this second column, I want to keep that as it is. It's a label, so I'll keep it as a label. This third column is a class information. So class 1, class 2, and class 3. So I'll keep that as a class. This first row here, so that's my include field. So these are the variables that I want included. So I'm going to say include on this dropdown. And then I have axis scale information, so wavelengths here. So I can choose axis scale. And then this third row I'm going to leave as label. So I'm going to say OK. Make sure I have everything.
What about that fourth column?
Ooh. Oh, I don't know. I must have missed it. Let me try again. Another way, so this time I did it a little different. I dragged and dropped it. And so this is our text import settings where you can, if you know how your spreadsheet is formatted, you can set certain things here. I usually just leave it at graphical so I can open up the import tool. But you can do things here like transpose and change the delimiter and things like that. Oh yeah, this fourth column, so it's empty, so it's not gonna bring anything in. For that. So I'm gonna say cancel. And then we have here our data set object of what we just brought in. So now let's actually open this. I'm gonna right click and say edit. And it's gonna open up our data set editor. So we see here, it's opened up the data set editor. So we have our first window here. It's gonna show the data tab by default. And we can look through these a little bit. So we have the info tab here. So this allows you to change the name or author. So I can click on this button here, this edit value button, and I can change this. Maybe I don't want the .csv name in it, and I just want, the gasoline NIR data, so that I can change the name and then make sure to click the accept changes button. So I can go through and do that for the name or the author. And then here's a little interesting thing. It added this include in the description field, and that's because it didn't really have a place to put that include label. And so it tries to find a place for all the labels. And then if there's not one that's appropriate, like there's no label for an include field, and so it puts it in the description. But we can easily get rid of that by editing the value. So this is where we have all our data. And you can go in here and click in these cells and change them if you want. We have a plot button here. I won't get into it. Scott's going to talk about plotting in a little bit, but you can simply click this button to bring up a plot of your data. And then here's where I think things get interesting, where we start to talk about and get the power of the dataset object and associating it with metadata. So here we have our sample labels brought in. So this is our label set, and notice we can have multiple. So it actually brought in our class information as a label as well. So we can have multiple. We can create a new set if we want, and then add new labels here if we're interested. So here's our axis scale. We don't have any axis scale information for our rows. And then here is our class information. And then I'll go to column labels. So you see here on our column labels, it brought in that wavelength axis scale information. So this would be very useful for plotting. And also here you can see on the far right, the include field, we have these first 36 or so samples or variables are excluded. They're not hard deleted. They're still in the data, but they're excluded and they won't be used in our modeling process. And we can simply, include these as we want. And I will say that this is just an example. The practice of variable selection is very important, and it should be done, with care during the modeling and during the exploratory analysis. So this is just an example to show you that if you know for sure you have variables that you don't want included, And so you can set them during the import process. A couple of other things. I'm going to close this. I'm going to close without saving. One more example I want to show is showing some metabolomic data. So I'm going to open this. So we have a similar spreadsheet. This is an Excel file. It's got similar information, and then we see that we have some additional information on a second sheet here. So I'm gonna import this. So I'm gonna go File, Import Data, Excel file. I'm gonna select that. So this is metabolomics data. So it's gonna, it has multiple sheets, so it's gonna ask me which one I want to import from. So I'm gonna say data. And I get the import tool window, so I'm gonna do the same exercise I did before, just a little bit quicker. So I'm gonna ignore this first one. I'm gonna bring this second one as labels. This class, this 1 and 0, I'm gonna actually bring that in as class information. This sex column, I'm gonna bring that in as label information. And then this M1, M2, M3 row, I'm gonna bring that in as a label. Say okay. And then my workspace is getting a little crowded, so I'm gonna do this little trick. I can highlight what I want to keep and then right click on it and say delete all others. And so just clean up the workspace a little bit. So now I have this dataset object, and let's open it up. And what I'm interested in showing here is if I go to column labels, see that M1, M2, M3, it's not a terribly useful label, I would say. And so what I can do is, and I know in my spreadsheet I have better label information. So here I have this label information, which gives the metabolites. So I can actually just select this column and copy it in Excel and then go back to my dataset object, and I can just simply paste it. And now I have a label for my variables that is much more descriptive and helpful. And so another thing I want to show and make everyone aware of is manipulating class information. So here I have class 1, class 0. So I'm going to right click on this class tab or field here and go to edit class lookup table. So this is going to bring up this lookup table here, and this shows me some information about my class set. And you see it has a class number 0 or 1, how many members, and then class name. So important thing to note about Solo and PLS Toolbox, class 0 is a special class and it's reserved for unknown samples. So don't use class 0 for samples that and so it should only be used for unknown samples. So I don't want this to be class 0. So I can actually just select it here in my edit lookup, my class lookup table, and I can change the value to 2, and then I can change the name to class 2 and say update. And so now I've solved that issue of confusing PLS Toolbox by setting class, having samples set to class 0 that I know are belong to a class.
And I'll mention there that you could have also assigned the male and female as labels right there too, instead of class 1 and class 2.
Correct. Yes. And so we did designate that male and female to come in as a label. Looking at it now, it seems like, oh, this makes sense to be a class. And what we can do here, we can right click on this label and say use as class. And it's going to add that to a new class set. And now when I click on this drop down on under my class, I see I have a new class set, and it corresponds to the male or female. And then yeah, so that's another way to get class information into your dataset object. Let's see a little bit more. Just quickly here, we can explore the dataset editor a little bit. You can export to different formats like CSV, SVC, things like that. You can do different editings like copy and pasting and things like that. You can fill a column with certain values if you want. You can do arithmetic on your data. So transform, you can do simple transform operations on your data set, like transposing or reshaping or flipping and all that. And so those options are there. You can also here in the toolbar, you can shuffle your data. So when you do that, it's going to ask you what dimension you want to shuffle, rows or columns, or dimensions 1 or 2. And I just want to shuffle like the samples. So I'll just say 1 and it shuffled those. So you can shuffle your data there. That might be useful if you're thinking about if you have ordered data and you want to do a certain cross-validation, perhaps shuffling will help. And
Hey, Lyle, I might just mention that the one time you might use transpose is that it might be that your data was stored so that the samples were in the columns instead of in the rows. And our software assumes that the samples are rows and the columns are variables. So if it came in the other way around, that's where you'd use transpose, for instance.
Yeah, thanks, Barry. Yes. Okay, I think this is all I really wanted to show. For the dataset editor, I know I took into Scott's time a little bit, but yeah, I think the really cool thing about it is being able to copy and paste from Excel into the dataset object. So, and then Scott was going to talk about the analysis interface.
Yes. Oh,
So let me stop sharing.
change my. Oh, Barry, you can hand it back to me.
And what's your name in here, Scott?
I'm Eigenvector 2.
You're the other Eigenvector research. Okay.
Yeah.
Okay. There you go.
Awesome. Okay. So once you get your data in, you're gonna take it and do an analysis on it, usually. And that will have you using our primary model building interface. We just call it the analysis window. And it follows the trends that we've seen throughout this presentation. There's right-click menus on most items that allow you to see what manipulations you can do. And in this, you can see sort of in this interface here, this screenshot, we have our menus up top, and then we have tool buttons for things that are common to do. And then we have a flow chart that shows sort of the process that we think you kind of follow when you're making a model. And then down in the bottom part here, we have the variance capture table, which gives you some statistics on your model. And I'll just run through here because it's really easy to do. And I'll show a little quick demo of this. So I'm going to drag my data over to Principal Components Analysis, and I'm going to drop it. It'll open up the analysis window with that data loaded. And in general, so we kind of work through this flowchart up here. The data is loaded. What's my next item? It's pre-processing. I can click on this pre-processing to see a menu. Our basic methods are the ones that are used quite often. So in this case, auto scale is fine for building a PCA model. If I wanted to do more advanced pre-processing, I would open up the pre-processing window. I'll note that you can show the pre-processing effects of pre-processing by clicking the show button here. Let's close that. And then if I go down the model, I can just click on this green area here, green icon here, or click the gears to build a model. And that's pretty simple. You get your variance capture table here. This gives you an idea what's going on here. I can see that 52% of the variance in the data is captured by the first PC. You'll get a little indicator over here of from a small algorithm we have to give you an idea of what you might choose for the number of PCs. You can change the number of PCs and recalculate. And then if you go back to the toolbar after you calculate a model, you can see the plots that are that we've decided are pretty useful. So you can open up an eigenvalue plot and look. Often you would use this to help determine how many PCs you might keep. We have lots of webinars on actually building models and analyzing data for particular model types. So I'm not going to go a lot into how you do that here. I'm just showing you the basics of creating a model and opening some of the plots. This is a scores plot. This is another plot that's used quite often. It gives you 3 subplots here. If you double click on one of these plots, it'll open up in its own window. And then you can manipulate it from there. And then, there's also other items up here, various tools that you can use, and you can explore those. And then you can also right click on these icons in the flowchart here and see what actions you can take with those items. And then you can see behind here, whoops, open that you get a quick summary of what your model is in this text window if you just mouse over. I'll go back to our PowerPoint here, and we'll move into our plot control interface. The name of the actual function is called plot GUI, and so we've kind of used that as a term. But this is really just how plots are controls. You can see there's one small window that controls all plots. This window has all the tools in it, and then what it acts on is the actual a different window with all your data plotted on it. I'll go back here since I have it open already, and you can see I have my plot controls here, and this is controlling this window. If I were to go up into this top menu, I can select a different window for it to control. Now it's controlling this window. And not only is it controlling this window, it's going to control the plot that I last clicked on. So if I click on this top plot, it's controlling this plot and ignoring these other two. If I click on the bottom one, it's actually controlling that one, and I can manipulate that. Now, the data that's plotted in there is, in this case, is an XY. There's samples along the x-axis here. You can see that here in this menu. And then scores on principal component 1 in the Y, and that's selected here. And generally, you would interact with the Y here to change what's being plotted. And you can cycle through all these, or you can select several. I'll go back to my other plot here that was just a single axis. And I'll show you that you can add a third axis to this and create a 3-dimensional plot. Those are kind of useful, and you can manipulate them by clicking on a tool in the toolbar here and spinning it around. If I want to go back to my original view, I'll click the home here. I'm going to turn off the Z on this. I'm going to go back to the PowerPoint real quick.
I'll just mention that we are having a webinar on May 4, everything you need to know about making great plots, because the plot controls window will do an awful lot of useful things, and far too much to cover in this right now. So that's coming up.
Yeah. There's a lot of functionality behind this. So I'll kind of go back to this. This is my little script that I wanted to show for today. So a lot of the the useful, things that we use often are included in the toolbar. This little ABC button here um, will add labels. And this is just a little dialog box that says that I can declutter the labels. I can include all of my labels, or I can include every other labels. We have a little algorithm that just tries to keep the labels from piling up on each other. Let's see what else there are. I can show classes. I think I have show classes on here already. If you mouse over these buttons, they show you what they do. They have a little description there. So I can turn my classes off so it doesn't show the information that the classes are groups, and this is just a grouping that we have for this data set. I can turn them back on, and it shows its color there. If I insert a legend, I can see that the red diamonds here are part of this K group or class. I can make selections too. So if I want to select a subset of data and do an action with it, I go to this button here. If I wanted to select all of these samples in this group, I can select them. One thing you'll notice about plots is that they're connected to each other. So this selection that I made here appears in these other plots. And this is really handy. So if you have one view of your data that shows a grouping that's easy to select in, but then you want to see what it looks like in a different view where it's not easy to select, this is one way of highlighting those samples. I think the last thing here is I'm not sure if I have if this is a super great example here. I am going to go over to here. I'm going to deselect all because I don't want that selection right now. So I'm going to deselect all from this edit menu. And I wanted to show the color by. This will take your samples and it will color by a value that you have that you can select from here. I'm just going to select the values on PC3 here. I'm not sure if this will really show us anything great about insightful into this data, but what it will do is it'll take that value and it will color each sample by its value on that variable. And you'll see us getting used in other circumstances, but it becomes useful when you really want to highlight a different dimension to your data, but you've already used the X and Y or Z axis to show your data. I think that's all I have for today. We're getting close to the hour here, so I'm going to wrap it up. Let me know if there's any questions in the chat.
Hey Scott, could you
Yeah.
turn on that plot, turn the color bar on?
Oh, right. Yeah. This shows you how the value is colored. And I forget what PC3, I think I'm doing PC3. I can't remember if that's actually heavily influenced by yttrium or not.
Yeah, so you probably don't see much structure there. I put Q as sometimes a good one to color by the residual because that then highlights in yellow your points that don't fit the model very well.
Oh,
And so,
okay.
Yeah.
So anything showing high or a high yellow indicates it's not being modeled well. Sometimes see if I turn my labels off by clicking that button again, it's a little easier to see. And as always, you can right click. You can right click items in here and manipulate them. I'll make the markers a little bigger there. Okay, so this is our last slide.
So I do have a question here. That's a good one. after you have a model made, is there a way to print all your model information into a report format?
There is.
There's a great way to do that, in fact.
We have a tool called Report Writer. Since I'm on Mac, it only offers me an HTML report, but on Windows you can use the PowerPoint or Word, and this will go through and capture all the plots, and then also um, a lot of the information on this summary right here, including um, a summary of the X block, your pre-processing, number of PCs, and your error calibration and cross-validation, along with a few other things. And that's really customizable, and you can go check it out on our wiki to see all the details for that. Any other questions?
Yeah, there's a question about how to save or export the PCA model you just built. Can the model be modified in MATLAB?
Well, yes and no. You can save it. I mean, you can export the model into sort of a flat file format, like a text format, um, or you could save it as a model object. I mean, and if we take a step back, the model is actually an object in MATLAB. That means it sort of has some structure around it that helps keep track of all the data that's involved in the object. And typically you wouldn't directly edit the model. You really edit the model using the interface. But you can save the model, and I could save it to a variable in my workspace, like this, and then I could go into MATLAB, and I can look at it and look at some of the fields that might interest me, and then I could pull information out of the model and operate on that directly. But I wouldn't add information to the model at the command line necessarily if I wanted to, say, change the scores or something. Does that answer your question?
I think so. It also brought up this how to prevent unauthorized change to the model in MATLAB. You can't. Okay. And uh, that's one of the issues about, so if you're working in regulated environments, then that's the one issue that's hard to get around with working with PLS Toolbox. So you have to have essentially version control going on your models in order to assure that people aren't doing that. Did I describe that okay?
I think so. This is the model building environment. Once you build the model, you take it into a different environment to where you're going to apply it and use it. And that's where you lock things down, I think, is what a lot of our customers do.
Right. Because it is used in regulated environments. Um, yeah, Neil noted that data set objects also have a history field. So if you start changing them, it actually keeps track of exactly what was done. I had another question here if, uh, oh yeah, so that was the question about the audit logs. And of course, our interface, and Scott, you might just show this as the model cache. You didn't mention that. So the model cache, which is shown there on the right that Scott has, keeps track of all the models and modifications you've built. So it is essentially an audit log for your modeling process.
Yeah, and you can see here that, when I initially built my model, I had one PC and I changed to 3 PCs, so it captured that over here.
And so that model cache keeps track of everything that you've done, and it's also easy then to pull old models back into your workspace to start working on them again from that.
Yeah, I can clear everything out of my interface here. We'll close everything down, and then I can load it up out of the cache. And if I load just the model, the cache knows that it's based on this data, and it will load the data automatically and show me what the status of my model was at that time.
There was also a question about if I import Y, the data must follow the X class, or uh, could Y have its own classes? And that one, I'm not sure I know the answer to how we treat classes that are different in the Y object than they are in the X.
That is a good question. I think uh, when you're modeling, they need to match, and it would generally follow what is, if you're using a class, what is the class in the X block, and the software would use that.
But the easy fix on that is that it's easy enough to copy your classes in Y into X. So given that X and Y have to match already in terms of number of samples in both of them, you can copy and paste them, and you can have as many different classes in your X block as you want and choose which one you want to use when you're modeling. Say you're doing a classification problem, and that's a class set for your classes in your classification problem. So it's easy enough to move them around. Okay, well, I think that's, let's see, if my near infrared spectra are referring to a certain concentration, I need to import the Y in the same sequence as the near IR. Generally, yes. We do have some tools, or there are some ways to match things up by sample name. And in general, though, the assumption is, given no other information, is that if you pull in a Y that has the same number of rows as your X, is that they're in the same order.
Scott, can you show the experiment reader real quickly?
That's what I was thinking of.
Let's see, import experiment file. No.
I showed an example in the import webinar of importing data and reference values using the experiment reader. So, if that interests you, you can go watch that. Also, we have if you do have an X block loaded, you can right click on the X block and you can say create Y from X. So this feature is changing in the upcoming release. Right now it's just create Y from X columns, and you can select a column here that'll create your Y block. Coming up, it'll allow you to it gives you more flexibility of how that works. But the idea being you could import your NIR data and your reference into your X block all at one time, and then use create Y from X, select your reference value, and then it'll put that in the Y. Is an option. And then you know that it's the samples are matched in both.
Okay, well, I think that's about it. It looks like the questions have dried up. So I'd like to thank everybody for attending. We will send you a link to this. It'll appear on our webinars page, and usually takes a couple of days to get it up there, but we'll send you a note so you can link back to it for review. And please join us then here in a couple of weeks. I believe it's on April 6th. Everything you need to know about how to do a principal components analysis model, and we'll show how to do that. So hope to see you there. And thanks for coming.
Thanks, everyone.
Yeah,
Thanks everybody for attending.